Okie dokie. Hello, everyone. Welcome to our 25th iteration of the Everyone Can Contribute Coffee Chat, or Cafe, as we call it. And today we stopped the Kubernetes learning workshop and do a little different topic, but somehow related, I suppose, or I guess. And I'm super happy that we will dive into monitoring observability with Opstrace today. It's a relatively new project, and I'm happy to welcome Sebastian and Matt today. And I would say maybe we start with a short introduction round to say hello, and then we kick us off, and Sebastian will do a live demo. And to be honest, I don't know what to expect, but we will have crazy ideas in the next hour, and I'm looking forward to it. I'm the crazy guy from Austria living in Germany as a developer evangelist at GitLab. I do love monitoring and all things, and I host it. And over to you, Sebastian.
Hi, I'm Sebastian. I'm the CEO and co-founder of Opstrace, and this is a project that Matt, I, and a merry group of other folks have started a year and a half ago and released a few months ago. And this is a super early project. I'm super excited to talk about it. And yeah, originally I'm French and German, but I live in California. This is where I'm talking to you from Southern California, but usually live in San Francisco. So yeah, very excited to be here and talk about all topics, observability, monitoring, and how to help end users with open source software. Matt?
Hey guys, I'm Matt. I'm the crazy Kiwi that is living in California. I am Sebastian's co-founder. We got together, after spending a lot of time in the infrastructure space, and we decided to finally, solve some of the challenges that we see in the monitoring and observability industry itself, particularly, with data governance, sending data, outside of your network, and also being able to just really control a lot of your costs, and really own your own platform instead of relying on others. So a lot of problems that we've been really, really excited to solve, and we're just getting started. So, we're excited to share a little bit about what we're doing.
Yeah, I could go next. Or do we want to do a full introduction?
Just go ahead. Just keep it short.
Okay, yeah. Okay, because I also like edge technologies. Typically in my day job, I'm working as a DevOps engineer or senior DevOps engineer. Mostly I'm doing blockchain and Kubernetes, so I'm doing only edge stuff mostly for work. And that's also the reason why I really try to see new technologies. Yeah, that's my chicken. Yeah. Michael, do you want to go next?
Of course. So my name is Michael. I'm from Austria, and I work as a product manager and software engineer at a company called ZKW Group. So we build headlamps for the automotive industry. And my day job is building high-performance compute stuff. So ray trace engines, CAD engines, and such stuff. And yeah, always try to learn new things and have won't always get into the trace business because I have to have normal Windows clients and not server clients, and getting telemetry data and such things is not that easy on the client side than on the server side. Easy.
Yes.
So I'm really excited what you will show us today, and I'm happy that you're here.
Awesome. Thank you.
Phillip?
Yeah, I go next. Hi, I'm Phillip. I'm also from Germany. I'm from Berlin. And to keep it short, I'm a Kubernetes systems engineer. And I'm also interested in observability and other stuff. I also heard Sebastian talking on Clubhouse. So I'm really curious to see it now.
Awesome. So you listened. Oh no, I spoke in French. I didn't speak in French. It was English. So yeah, cool. Awesome.
Lucky for me, it was English. Yeah. And I didn't have to learn a new language, but yeah, it was English.
Chris, you joined us. Chris is from our team.
Yeah, hi guys. Sorry for being late. I'm Chris. I live in San Francisco. I worked with Matt and Seb at Mesosphere. And prior to that, I managed the Mesos team at Twitter back in the days when it was pretty nascent and growing. So, there was a good chapter in the industry and looking to write the next one here. So happy to be here. Thanks for having us.
All right. Anyone else wants to do intros? Otherwise, happy to get going.
You can get going.
All right, awesome. All right, I'm going to share my screen then. All right, just a second. There we go. All right, desktop is shared. Let's over to the browser. So Opstrace, very happy to be here and talk about what we're doing. So like I said a bit in the intro, Matt and I got together about 2 years ago to decide to build a company, and we're from the infrastructure space. And our goal was to find ways to help people with all the wonderful open source software that exists today. And after talking to a lot of companies and a lot of users, and also looking at the things that we liked ourselves, we decided to go and help in the open source observability business. Why? Because there's so much potential in there that is untapped and that is not easily accessible to end users and to companies that of various sizes. It requires a lot of experts to do this. And this is, we're talking on a GitLab channel. You know a lot of this as well from your perspective in terms of what you're doing, but it's not an easy thing to use open source software. And we didn't immediately have the idea to open source this, but now we're here. And the idea is to say anybody should be able to start using open source observability tooling like Prometheus, like Cortex or Loki. These are the technologies we've chosen without having to become an expert in them. And an expert is someone who everybody can become an expert, but it requires time and dedication. You need to learn a lot. And so this is what companies do as a choice. They have to either buy a solution or they have to invest in open source tooling and become experts. So we chose a more narrow path than before. Before we were in the container orchestration world where everybody could run whatever they wanted on top of the infrastructure that we were building. In this case, we decided to go a bit further down and to choose a piece of the stack that is necessary for that world, but not something that has to be like everything for everyone. That might not be the right way to say this, but we'll get there. So in the end, we decided to call this an open source observability distribution. The idea is that we assemble open source, a bit like a Linux distribution. We assemble different open source pieces from the open source observability world, and we make it usable. We make it secure out of the box. We test the upgrade path. All of these things that are very hard to do over time. We'll be doing a demo about this today. This is an early project. Today we have an installer. We have a lifecycle manager, if you want. We call it a controller. It's a Kubernetes controller that runs on top of a Kubernetes cluster and manages the entire lifecycle of this distribution. The goal is for the system to be able to accept metrics, be able to accept logs, eventually also traces and other like singular events that infrastructure creates, but in staying up in a way that is just as easy as using a SaaS provider. So this is a long goal. This is a big goal, but it's an achievable one because this is something where there are no technical problems that can't really be solved since, yeah, that's it. Why a distribution? Well, we wrote a little bit about this yesterday. We introduced ourselves, so I'm going to skip Matt's introduction but why a distribution? We wrote about this yesterday. And a distribution is important because we wanted to find a lens to explain what we were doing in a way that is relatable to others, that people have seen before. And a distribution says you can come and build together to build this a platform that everybody will be able to use, right? Like a distribution says, we will be packaging things, we will be installing things for you, we will be helping you with upgrades, and we will put all the features in there that you need in one place and in an opinionated way. In this case, Opstrace is, we chose certain projects very precisely because they have some characteristics that we needed. For example, we're built on top of things like Loki and Cortex, and we didn't choose them for no reason. We chose them because they store all their, while they use the principles of Prometheus, they store all their data in S3 or in Google Cloud Storage. And that is important because to be able to monitor and log things at scale, things need to be eventually cost effective. You can, and people need to be encouraged to send more and more data to their platform. And people are discouraged by doing that when there's a price on each exact metric. And there's still a price when you write to S3, but the advantage of doing it this way is that you can write much more, keep it for much longer than, for example, a SaaS provider. That's the idea. So Cortex and Loki embodied those characteristics because they chose to build a horizontally scalable system that you can throw logs and metrics at, and then continue to still horizontally and vertically scale without having to worry too much about the complexity of the system. At least that's the theory. In practice, you have to learn, again, a lot about Cortex, a lot about Loki to be able to set them up. That's what we did in Opstrace. In Opstrace, we codified it. We created code to install, deploy it, manage Cortex and Loki, help test it end to end. And what I mean end to end is on one hand you have the correctness of the system. Is it still firing alerts? Can I trust it? Is it up? Is the data that I'm sending and reading back correct? That is one thing that we test. And on the other hand, testing upgrades, testing a path to allow people to move from one version to another, especially in fast moving software like all of the open source software that we use today. The open source software that we use today is very fast moving, changes all the time. So we need a way to channel this. That's what Linux distributions do, but we don't have this so much in the observability world. So that's a very high level description. In the end, what Opstrace is a simple command line. To start with, you deploy with a simple config an entire system in your cloud account that enables you to ingest logs, metrics, eventually traces, and then set up alerts. We have more plans for this. We have the idea is that we have quite an open roadmap. This one is the idea is there are things that we want to build that don't exist today in the open. Like, for example, the total cost of ownership detailed in the UI, like the system, since it's running in your account, should be able to tell you exactly how much it costs. When you increase the number of nodes, when you start sending more metrics to it, we want to help with things like better UIs to do alerts. Alerts are not an easy thing to do. And today, like with Prometheus, it requires you to know and write a lot of rules and become an expert in how Prometheus works. This is something that we want to abstract and put into simple visual UIs that people can use to, in the future, do more with it, like SLOs and error budgets. I'm going to move over to the Quickstart now. Since I've talked a lot at a high level, I'd like to show more exactly what we're doing, but I'll pause here if there are any questions or commentaries. No? All right. Okay. So quick, our demo. So the quick starts that actually takes a half an hour to start up. Unfortunately, it's not that quick. Is an example that we show on our website to get a cluster up and running. I will show this. I will run through it today because it allows us to see different parts of the system and how it's being used. So I have an already running cluster. So since it takes 30 minutes, we're not going to be waiting 30 minutes, but I'm going to kick off and install just to show you what it takes. So here's my terminal. So in this case, I'm just following the Quickstart. It works on Mac and Linux, of course, for the CLI. This is a TypeScript CLI that is basically compiled to a single binary, so that's with all the requirements in one place, so that you don't have to have a node install or any other complicated things on the end customers or users cluster laptop. So the simple CLI allows us to create, destroy, list clusters, and upgrade clusters. This is the goal of the CLI. Eventually, we'll have more of this in APIs and also in ways to interact that are not just from in a CLI purpose, but this is a great way to start and to get a whole to go experiment with the system. So the we're going to choose a name. In this case, we can say ECC Opstrace, and this we have a config that is quite simple. So this is the minimum amount of stuff that we require in the config, or at least we could remove a couple of them. We show an example. So Opstrace is a multi-tenant system. We have multiple tenants. In this case, by default, we create a development, a staging, and a production tenant. Each tenant is isolated and can query its logs and metrics and get metrics sent separately. By default, we also use Let's Encrypt to get TLS on our interfaces. So now we're going to kick off the install. So the install here. So the install here, it will ask us to review the API calls. This is an interesting thing that we can have a look at. Each build, so we call a lot of APIs inside of a customer's or a user's cloud account. So every build of Opstrace generates a kind of list of all APIs calls that are going to get called. This is whether it's in AWS or in GCP. In this case, we see a list of all the APIs that we are going to be calling to be building an Opstrace cluster. This is not perfect. Eventually, we'll be able to show more details about what happens in a cluster, but this is to try to reassure the user that what's going to happen. So once we launch this, what happens here is that the CLI uses the cloud account's credentials to go create a cluster. The first thing I've been redirected to a login screen. This is because we've created an ECC Opstrace name. This will create an ECC Opstrace.opstrace.io domain. So we require people to authenticate to be able to get that domain. Custom domains are something that we want to build, custom authentication, custom domain, but we wanted to start with the very easy approach of giving people a domain, giving people a way to authenticate with their clusters, because these are the kind of frictions that you can see in the open source world. As soon as you need to set up domains, TLS, you need to talk to other people in your organization. It's not that easy. So this is a way to just get started right out of the box. Now what you're seeing is basically a log of the cluster getting created. And the cluster, we start obviously with all the AWS resources that are needed to create this. The CLI is entirely reentrant. If I Control-C this and start it again, it'll just go back and go back to where it needed to be done. You'll see that I'm not going to get queried for DNS because DNS has been set up, and we continue where we left off. This is true for install. This is true for destroy. There's nothing more frustrating than like closing your laptop and everything's gone. So as I said, we will not be waiting half an hour for this one to come up. We'll come visit it a bit later. In the meantime, I have one that is fully up called ECC Demo. I started it this morning. You can see like the logs all the way to the ends. I mean, we're not going to go through them in detail, but suffice to say, what happened here is first a VPC was deployed. Then in this VPC, we deployed an EKS cluster. Then on top of this EKS, then we also create an RDS database for our config. We create the buckets that are needed. And then on top of this EKS cluster, we deploy the Opstrace controller. So we're not deploying a bunch of Helm charts in there. We deploy one piece of codes that's and that's the repository that you can see on over here on this repository. All the code is in there. Like I said, everything is open, but the controller gets deployed in the cluster and then starts deploying everything that is needed to run Opstrace. So it deploys Cortex, it deploys Loki, it deploys the Ingress controllers, Prometheus, and it also deploys the custom Opstrace UIs and APIs. So once that's done, we can actually just click and go here to eccdemo.opstrace.io. I have pre-opened the tab, and so well, I have not. So let's click. There we go. So the tab basically gets us to our very bare bones UI. Remember, this is an early project. Our goal is to showcase what we're doing here. So the bare bones UI, it doesn't show much. What it shows today is we have a couple of tenants. I talked to you about dev, staging, and prod. System is a default tenant in every Opstrace cluster because Opstrace clusters monitors themselves. I can add users now here, like for example, matt@opstrace.com, and he will be allowed to log into the cluster. The login, I should log out to show you the login. So let's see. The login is quite straightforward. It is this, we provide it through Auth0, so that's like you can just log in right away with the email of the account that you use to create the cluster, right? Like, so I created the cluster with seb@opstrace.com, so I'm allowed to log in. I'm added Matt is allowed to log in. Again, like this is our first step for authentication. The goal is to put things like DEX or other inside of the system to be able to allow full custom authentication with OAuth, OpenID Connect or SAML or things like that. But this is where we start because this is to make it very easy and work out of the box. So once you're logged in and you see the multiple tenants, well, we can actually do one thing. Every tenant has a Grafana instance. So let's go to the system tenant. The system tenant has a Grafana instance, and we can just see some default dashboards that we've put in. We have dashboards for the Kubernetes system underneath. We have dashboards for Cortex, Loki. All the default dashboards are in there. This one is a default dashboard for the Quickstart. So what do we see here? We see that at the top that our tenants are not sending any data, but we still have some active series inside of and active logs inside because the system monitors itself as well. So so we can see that we have around a bit under 125K active series by default, or well, 121. And then we have an ever increasing amount of logs getting created by the system. These are going into Cortex and into Loki as well. So the rest of the quick start is I'm going to start sending data to the system. So to send data to the system, I'm going to do it from my laptop. In this case, we're going to simulate what you would do if you had, for example, a Kubernetes cluster or an Amazon instance or whatever that you want to use Prometheus and Fluentd to get the logs and metrics off of. So I'm going to be running I'm going to create a config for Fluentd and Prometheus. This is the config. The config will go get metrics from a local container, and the way Prometheus is configured to talk to Opstrace are these few lines. So we put in the URL cortex.staging. So we're using the staging tenant. We're sending it to Cortex, and we're sending to the ECC Opstrace. Well, in my case, we're going to use the one that I created. So it's ECC demo. Okay. So the cluster is eccdemo.opstrace.io, and this is a normal Prometheus remote write push for those that are familiar with this. And it is authenticated with a token. The token is, I will show you here. Right now, it is generated when we create the cluster. Eventually, you'll be able to download them from inside of the cluster. For example, in this case, it'll be the staging token. These are, I mean, there's not much to see here. It's just to show you that these are standard JWT tokens that are used to authenticate with the system. Why did we choose to put authentication and TLS in there by default? Because it's always left as an exercise to the user in for open source. And also, we noticed that companies setting up and building on top of open source simply don't set it up because it's hard and complicated. So that's not a reason not to do security. So there we go. So let's create this config. Fluentd is the same way. If you're familiar with Fluentd, same thing. There's a new URL to send the logs to, and there's a token to be authenticated. So again, here we copy it. Oh, sorry, wrong copy. There we go. And then last but not least, this is less interesting. It's a Docker Compose file that runs Fluentd and Prometheus locally, as well as a container called Avalanche to just Avalanche is a scale tester for Prometheus, and it allows us to just generate some logs. So now we're gonna bring that up. No, come on. Okay. That is a fail on my side. Sorry about that. So, okay, nervousness kicks in. Okay. Thankfully, Linux distributions are not too bad. That's what they help you with. Yeah. So now we're creating the containers. There we go. Still pulling them. Why? Docker logging driver. Why does that not work here?
Does some more things already run on the pod?
Let's see. No, nothing is running. Let's see. This connection refused to what? Give me a second. Logging driver.
Oh, yeah, Docker daemon probably.
Let's see. This is ECC demo. Yeah, okay. Why is this not working? Apologies, this is not normal. This has to do with my local Docker.
Can you check Docker info? Probably because it seems that you configure the system loading driver to use Opstrace or another tool.
Logging driver JSON file is the normal one. Okay. This is definitely something with my Docker install. This is not okay. Okay. Let's see what we're gonna do. All right, give me just a second.
Can you, JP here from Opstrace,
yeah.
Can you maybe open the Docker Compose config again?
Yeah. Let's see. This is this one.
What does those Fluentd address?
Oh, I got it. I found it. No, I found the problem.
Okay.
I found this is it. This is it. So we're gonna move Opstrace Quickstart here to Opstrace Quickstart live. This is and then we're gonna move ECC demo to Opstrace Quickstart. And we're going to go to Opstrace Quickstart. And we're going to do up.
That logging driver topic is about collecting the logs from those local containers, right, on your machine, right? We don't even need that at all.
Okay, I fixed the first problem. Opstrace demos.
Like we specify this Fluentd logging driver there, and then maybe we can just remove that from the config.
Where is it?
Like in this Docker Compose config YAML.
Oh, that's weird.
You see those, localhost 2.4.
No, okay. So basically, these containers are not coming up. So this login driver is not happy. This logging driver is not happy either because Fluentd is not coming up. So the question is why Fluentd is not coming up. So Fluentd is not coming up for some reason. So let's see fluentd.com. Apologies, I moved directories around and stuff like this, and this is never good. Okay, so Fluentd there. Docker.
Don't worry, we love debugging here.
Okay,
for sure.
Awesome. So the Fluentd here created up. Wait, it's status up. Okay, so
if we can have a peek into the Fluentd container log, it will show us the problem now.
No, everything's working now. So what the problem was that I had created a directory called Opstrace Quickstart. Then I renamed it to ECC demo. Then I showed you how to create a new cluster in Opstrace Quickstart. But when I copy pasted everything out of the Quickstart, it still had like basically my full path in here.
So that was an RTFM problem.
Yes, no problem. So everything's up and actually sending, the containers are up. So they're sending data to this. So now we're going to actually go to this URL here to see if it's coming in. So now we're going into the staging tenant. So not the system tenant. So it's another Grafana instance. So if you're familiar with the, what's it called? Let's see. Metrics. Why is the query not going in there? That's weird. The URL looks bad. Query. Oh no, it's just oh no, I have to, sorry, again an RTFM problem. So here we go. Here's the query to put in. And there, sorry. I'm just checking here. This is the data coming in, and then the quick starts. Sorry, let's zoom things moving around. Here we go. So we're going to copy the whole thing here and put it here. Okay, so moving around, this is not ugly data, but you can basically see that this is the metrics from Avalanche. So Avalanche generates random Prometheus data with a lot of different labels and is currently getting sent from my laptop to this staging tenant inside of the Opstrace cluster. So the staging tenant is the same Cortex, but its own Grafana and its own authentication token, right, from the other tenants. And so imagine this is how you would separate, well, staging, prod, and other environments, however you want to decide to split them up. And so the cool thing is that if you're familiar with the Amazon Grafana as a service that they launched, right? You basically go to Amazon and you say, give me a Grafana, give me another Grafana, give me another Grafana. Well, this is this, but for multiple clouds. You do this on Amazon, you can do this on GCP. And if people continue to work on this together, like you will have this on Azure and more things. And when I say people, is like the use cases for where to run this are very vast, and it requires a big community to basically get it to run in a lot of different places, just like Kubernetes did, for example. So this is the data coming in, and let's continue in the quick start. We can also go see, well, we're not going to go see that the prod tenant is empty. That's not that interesting. Where I think we all understand here that if we're only sending data to the staging tenants, it's only there. But what we can go see here that is interesting is, let's see. Sorry about this. It's moving around. This last 3 hours. Let's do last 5. That's 5 minutes. Okay. I'm not sending enough. I don't think I'm sending enough for this to be interesting. Okay. Back to the rest of the Quickstart. So I showed how to add a user. I want to move on to another part of the demo. So we have so we have logs is an interesting part. So obviously this is not just metrics. This is also logs. So this is a typical Loki / Cortex setup. So you can actually go from metrics to logs. So these metrics have a label called Quickstart. If you go to logs, now Grafana allows you to basically switch to a logging view and see the logs that correspond to the same label. If people are not familiar with how Loki works, Loki is a kind of a Prometheus, but for logs. So you have, the way it works is you have labels, just like in Prometheus, and then you have a value, which is the log line, instead of having a metric. And obviously this is where kind of the comparisons kind of stop, but what's cool about this is that you can pre-index your logs to do kind of to be able to go do nice distributed greps on top of them, right? So this is not a full Elasticsearch type of setup where with Elastic you build a huge, complicated but very useful and expensive index where you can then ask any questions. That's cool. But for most infra logs, we believe that's like for 80% of the cases, people want a distributed grep. And a distributed grep is basically, I go filter it by a few labels, just like I do for Prometheus. And then we have a horizontally scalable system that fetches the logs from S3 and goes and you greps basically what you need out of them, and you can tail them. That allows you to do a lot for in a very cost-effective way compared to an Elasticsearch index, which requires live machines and requires a lot of RAM and a lot of disk space, which in the clouds in the cloud world are very expensive. So this is to showcase like this. Both are coming from my laptop, right? Like the logs, the metrics. What we can do beyond that is we can set up things like alerts and alerts, for example. So alerts are interesting. We've barely started with alerts inside of Opstrace. What we've done is decided, let's make the alert manager from Prometheus and Cortex very easy to use. How do we add things to it to get it so that an end user can use it without too much complications? So first we start with things that are quite table stakes, which are putting APIs out there to be able to accept rules and accept alerts with simple curl commands, if you want, right? Like, so for this, we simply transparently proxy what Cortex gives us. Cortex gives us a way to send alerts. Cortex gives us a way to send rules, and we proxy it with an authenticated token. And then it is quite simple. I'm here in the docs. So first you post a typical alert manager config for those that are familiar with it, and then you need to have the token to be able to post it, and then later down the road you post actual rules to be able to go be alerted to this case. In this case, this example in our documentation uses a system called Deadman Snitch, which allows you to know if the alert manager itself is down or not. And so this is an example here of how that you can simply post simple YAML to this API, and then you will start basically be able to go to the alert manager UI. Let's see, I have that we can actually do right now. So Alert Manager UI is available in every tenant. So if you delete all of this, it's not configured because we haven't sent something. So let's configure it. So we want to configure the Alert Manager for staging. All right, so let's do this. Oh, sorry, Zoom is, I'm going to move Zoom here out of the way because it's really annoying. All right, so in the Quickstart, to configure the alerts, in this case, like I said, we're going to use a very basic thing. So let's see. Let's take this URL here. We're going to have to change the URLs, but that's fine. So what are we changing here? First, we have to put staging here, obviously. This is for the staging tenant. And then the staging token. And then that's it, actually. Oops. Oops. Sorry. No, of course. This is ECC demo. Never mind. So this is ECC demo because ECC demo is the name of our cluster, and the tenant is derived from the key that is sent to this interface. So now the Alert Manager should be configured, and we should be able to actually go here. There we go. Now we have a functioning Alert Manager. So for those that are familiar with this, this is the normal Prometheus interface. And this one is served from Cortex. It's empty. We don't have any alerts. So now we can actually go and simply create a couple. So we're going to take this one. Of course, I'm doing it with curl. We also have a UI to submit them. I'll show it in a bit. We're still finalizing that UI. So staging again. No, this is the same one. Sorry. There we go. So staging, and then here is ECC demo. What do they do? This is not command, obviously. There we go. This is not right. Sorry, I must have pasted something wrong. Let's start again. So staging. Actually, success. Oh, never mind. We should be better in our API. Like I saw error, but I didn't see there was success. So we already have one. So let's go see in the UI. There we go. Found. Are we in staging here? Almost done. Give me a second. Just checking. Let's curl it. See if we have it. That's a good way to do this. Here, so staging and then ECC demo. Yep, it exists. Yep, everything is in there. Okay, so back to Alert Manager. Why does it say no group found? That's a weird thing. Config is there. Let's see.
Did we use the correct Alert Manager? Or was it
That's what I'm checking.
Instance?
That's what I'm checking. That's one of the things with it. Which tokens? I sent staging token, staging token. I mean, we can cycle through them. That's easy. but this one is not configured. See, staging is the only one that's configured. So, oh, there it is. It just takes a little bit. So you have to understand that the way things work here is we submit it to an API, then we write it to our configuration database, and then things have to be synchronized into Cortex. They have to be synchronized into Cortex, write these databases, these configs to S3. I'm a bit like finicky here. Things do end up working when you have patience. So there you go. We have our example. So I'm not going to hook this one up to a Slack because it's a bit redundant and boring. But the idea, because this is what you can do with normal Alert Manager, you can actually go and create these as you want. That's the first step. We want to also allow you to look at these things through a UI. Right now, obviously, this is very limited, very basic. This is just a way to submit the config itself and the templates through the UI, through an editor, but the editor validates the config. So all the, like I was lucky to have correct config here, but like if you, for example, try to publish a broken one, it will validate it. Templates are another thing that are useful for Alert Manager. Templates are how you configure Alert Manager to create the nice messages in the emails or the Slack alerts. Currently, we're doing this through this editor, but we're currently also, we have a PR open to work on a CRUD, a very simple CRUD UI for these kind of alerts and rules. That's where we're going to start. And then roadmap wise, the idea is, okay, that's great. Now we've created ways and UIs to set up alerts. What's the next step? The next step is, if you've ever heard of SLOs and error budgets and try to set them up with Prometheus, they're awesome and you can do a lot of things with them, but they require you to set up 20 or so rules and they require you to be quite an expert in Prometheus. Now that we have basic UI and now that we have basic APIs to do this, we want to build higher level tools to be able to generate those rules, to be able to generate those things for the user. So that's where the system is going. Opstrace right now is a lot of the table stakes to enable these higher level user interactions and features, right? Like most people have never heard of an SLO or an error budget and how to do it right. Why? Because it's scary from all ends, like whether from the definitions, what it is, what it means, and also how to implement technically. We want to remove that from that. We can't really show anything about this now. These are ideas that we can talk about, right? And then the last thing that I wanted to show for the demo is quite cool. So what is this guy doing here? Is monitoring cloud vendor metrics. So it's great to have Prometheus, but Prometheus also is, the power of Prometheus is to be able to couple it with a lot of exporters. Exporters need to be deployed, exporters needs to be installed. When you have an instance of Opstrace, you want to utilize these exporters to go get metrics out of things that are not in Prometheus. Like, for example, GCP, GCS metrics or S3 metrics or cloud, anything that's in CloudWatch for load balancers. All these things don't exist in Prometheus and you need to go get them with existing exporters. So in the tradition of how we've built the system, we've integrated the exporters, but we've integrated in a way where we created a multi-tenant API where you can simply, with your token, first submits the AWS and or Google credentials that you're going to need to go get, since you're watching multiple different cloud accounts. Opstrace runs its own cloud account. So if it's going to have to go query CloudWatch metrics from other cloud accounts, whether it's different clouds or the same cloud but different account, it'll need tokens. So we created an API to submit tokens, to submit credentials, to store them on the Opstrace side, and then so that they don't have to be in the configs themselves. And then we also allow you to submit these simple YAMLs to basically create these exporters and start scraping things. For example, this example here will deploy an AWS exporter inside of the dev tenant, and it will go get CPU utilization for instances, all metrics that are in the namespace BuildKite. We use BuildKite as our CI system, so they generate metrics. This is how we can scrape them out. Doesn't matter. Everything you can configure inside of this exporter can be submitted to this API to generate multiple instances of these exporters that go get multiple things from different providers. See, we have work. We have to add a screenshot here. GCP is the same way. Like you want to go get things out of Google APIs and say how often you want to scrape these things. This is how you submit this. So this is an example for Stackdriver. Same as above, same as CloudWatch. Go get the metrics where they are. Go get the logs where they are. This is our system to enable this. Another example of an exporter that we don't even have docs for yet is let's see, I have it here, I think, the Blackbox Exporter. So for those familiar with the Blackbox Exporter, it's a way with Prometheus to do a live HTTP or pings or DNS probes, checking if a DNS node still exists, checking if an HTTP server is still up. You configure it with this kind of configuration. You can go look it up in the Blackbox Exporter documentation. We allow you to deploy as many instances of this exporter per tenant as you want, right? Like, so you can go actively, not just receive metrics, but you can go actively monitor if certain things are up. And then how we're going to build on top of this, we're going to use something like this Blackbox Exporter to, in the future, create something like synthetics. Synthetics are a weird name for active monitoring done from around the world. Pingdom, for those that are familiar with it. Well, with once you have actually a cloud account and APIs you can program against, doing a world ping / pingdom / synthetics approach to monitor your uptime from different parts of the world becomes, okay, I need to deploy a container like the Blackbox Exporter somewhere. I need to deploy it with something to scrape it, like a Prometheus. These are two containers that's quite cheap to run with Cloud Run or with ECS Fargate. And we can actually orchestrate that and deploy that in different parts of the world with the cloud account that Opstrace is configured with. I hope that makes sense, but this is to give you an idea of how one can build things in the open by just by utilizing what's there and improving on it. So yeah, these are examples that we have. This is I'm not going to destroy the cluster yet. Like I'm going to leave it up if there are questions, but I'm going to stop here and ask questions, discussions, because this was a very long demo, I admit. So there we go.
Probably I have directly a question because we can also directly talk about the exporters. So currently, what would be the case when I want to bring up my own exporter? So like I have, for example, another CloudWatch exporter that's currently written, and I want to use this instead of the standard CloudWatch exporter.
Mm-hmm. That's a good question. It's a thing that we like. Currently, the way they are integrated are like you would have to go edit this Go code, right, to add this capability to it. It's not that hard, right? It's done in a way that enables that, right? So that's why we added the Blackbox Exporter. We first had the exporter for AWS and the other, and we want to see what does it take to add another one and another one and another one. So yeah, it takes editing code and adding it to the system, but we're happy to come up with an idea, right? Like that's the goal. Like we won't know until people like you come and say, hey, I have this special exporter here. I need to use it. How do I do that, right? Like,
yeah, that's true.
Right. Any other questions? Right.
I have a question. So everything was basically Kubernetes focused now. If I don't have Kubernetes, how can I use Opstrace?
Mm-hmm. That's a very good question. So Opstrace itself uses Kubernetes, but that's hidden away, so to speak, right? But in our case, yes, we started talking about how to monitor Kubernetes clusters because that's where the Prometheus world kind of like really like took off. But we're also working, for example, with one of our customers that uses ECS. And so when they use ECS, the world is a bit different but they can still use Prometheus, they can still use Fluentd, right? And so that's an example. Or if you have single instances, for example, a lot of people have single instances, then you have options. You can keep using Prometheus, but if that's too big, you have things like the Grafana agent. You have, we support the Datadog metrics interface, but that's more for migration. I wouldn't use it. I wouldn't start using it to monitor single instances. But yeah, cloud. What we decided to do is let's embrace APIs that are open, like Prometheus, like Loki, and so that you don't have to be using Kubernetes to send us data. Open telemetry is one of the next places to go, right? Like to continue to make this bigger. There's the open telemetry collector that could be deployed and utilized a bit like our exporters here, as an example. Does that answer your question?
Yeah, and I have a new question as well. Thanks.
Cool.
So if you're talking about like you want to integrate open telemetry, does this also involve like using Elasticsearch data instead of Loki? Like how far do you want to go with opening up or using APIs or providing data sources? Because I could imagine that this at a certain point you get into maintainer hell somehow, because you need to support a lot of interfaces, and maybe you probably have made plans around this, how to make it easier. And I would love to hear your thoughts or your roadmap. Yeah, absolutely. So it is true. Like one of the main purposes when we started was to say, it becomes insane to have to maintain 1,000 like different projects, different APIs. So which ones are the best for what? And you mentioned Elasticsearch. There is a need for things like fully indexed logs, right? Like that is a thing that's needed, but you don't need it for 100% of your data. So what we want to do is enable you eventually to deploy with Opstrace, Elasticsearch, managed by Opstrace, or Elasticsearch, OpenSearch, whatever the winner. But like deploy that and send a percentage of your log traffic or tracing to it, right? The one that you deem useful. And so the way we want to do this is, like we want to be careful about the APIs that we choose. Thankfully, OpenTelemetry is kind of trying to get things to one kind of API. We'll see where it goes. It's still super early. And then in terms of backends, we're trying to build something not a distribution that has thousands of packages and thousands of choices, but a couple that are well tested, right? One thing that I couldn't show in this demo is like everything in here is completely tested through and through, right? Like we test for correctness. We have CI for everything. That's one of the important things. And you can't do that if you widen the area too much. But if you focus just on a few, the ones that people want to use, you can actually can make that quite robust, right? Yeah, I would totally love to try it out, and I need more time. I was wondering, I've seen a blog post, I think yesterday, where you discussed that you want to be fully open source. And I was wondering what made this decision? Is there anything which could be what is your way to make money with Opstrace, to be honest? Cool. So the decision to go open source is, if you want a community around these things, right? Just like for things like Kubernetes or others, like you can't have something where it's crippled in some way, right? Like, for example, have the security features closed. That's something that happens very often, right? Like, so we decided to go fully open source because we believe that if we build this distribution out, we can do what we do with our current POC customers, which is run it for them inside of their accounts. So we can actually sell a subscription to an open source product, and we can then manage it for the customer in their account. So what we're building as a company is not just this product,
like that's the thing that we need to build with a lot of people together, but it is also building some kind of distributed SaaS if you want, right? So instead of managing one big SaaS where we run Opstrace and people send us the data, we actually get people to run Opstrace in their accounts, or we run it for them in their accounts, and then they pay us to keep it up, not just for the maintenance of the distribution, and not just for the support, but for the actual act of being on call for that infrastructure, right? When you use Datadog today, you don't wake up when Datadog, well, you do wake up when Datadog is broken. It's a big pain in the ass, but you don't wake up to go fix Datadog. Datadog's team fixes Datadog for you. Well, this is the same for us. When we're going to be running Opstrace inside of the customer's account, we fix it for them if it breaks. And that's why we're building Opstrace in this manner, in this more restrictive manner, to allow to manage not just one, but thousands of instances of Opstrace in the similar way as you would one. And if you do that from scratch, then you can actually do it, right? Like it's not that different from a big central SaaS where you have to manage thousands of users in one place. Does that make sense?
Yeah, that's great. I was just thinking of like, if I'm, for example, located in Germany, I probably don't want to have the data in a different data center rather than in Germany. So my follow-up question would be: are you planning to, for example, provide European hosted instances, or like close to my DMZ or something like that?
Yeah. I mean, that's why we build it this way. We built this way because, I mean, the region here, look, like the region is freely configurable well, okay, this is an exporter, but the region is freely configurable everywhere in Opstrace. You run it in the country that you're in. That's the entire, because not just the country where you're in, but your cloud account close to your firewall, right? Like all of the above. That's the only way to run Opstrace. And more importantly, you probably don't, like, if you have serious infrastructure, you probably don't even want to run your monitoring system in the same Amazon region as your other Amazon stuff, right? Like regardless of countries, right? If you have all your stuff in US East 1, why would you put your monitoring in US East 1? Today, people put their monitoring in US East 1 when they build it themselves, because it's so much work to do multi-region stuff that's like, that they have no choice. That's what we want to provide. We're saying you can take Opstrace, you can run it anywhere in the world, any region, and it's made to be run on the internet. It's made to be exposed on the internet, right? You can firewall it, you can do all these things, of course, but it is made to be there and to just, that's why I do the demo from my laptop. When you use Datadog, when you use a SaaS provider, you start sending data and that's it, right? Like if you want to add restrictions on top of it, great. So yeah, I added a bit more to the question, but
no worries. I'm trying to like push you into the thoughts, because I know that like the requirement of having the data in the cloud but still next to me is a strong one, and there could be a strong requirement for decision makers. And just to add to your point with like, you want monitoring in a different region, probably want to have like agents in different regions, providing me a distributed view on my deployment, on my application. So monitoring or observability tools should probably always be outside of your stack or outside somewhere. And you also probably need to build something which monitors the monitor, because if it breaks,
exactly.
So I know that you could use Thanos or Cortex for distributed Prometheus as a distributed Prometheus backend, and using it also for high availability. Is that something I get out of the box with Opstrace?
Yeah, so out of the box, I mean, I haven't gone like enough into details about what's in there, but like when we say we run Cortex, like out of the box, it is 3 nodes, right? Like, and if one dies, another node comes back to replace it. Typical Kubernetes / cloud type of world. And yeah, it's a horizontally scalable Cortex and Loki in there that inside. But then if you want to monitor Opstrace itself, well, we ourselves use Opstrace to do that, but and to monitor our customers' ones, but and our CI and stuff like this. But down the road, like depending on your needs, like and on the size of your organization, you can stack things, right? Like,
yeah, I think that's great, and I would probably recommend to focus the marketing a little bit on that, because for me, high availability and redundancy is super important. So I've been building monitoring systems while you have active setups and you do failover and other scenarios. And I know it's really a business requirement to have it. And focusing on that, you probably have a blog post or website already, but I could see this is also similar to what makes Opstrace different to like a standalone monitoring tool, which you install on a virtual machine and it breaks, and then your monitoring is dead, which is bad.
Yeah, no, that's exactly it. Like how do you monitor at scale is that's the biggest reason we started this, right? It's like monitoring at a low scale, it's one thing, but like where people really start running into trouble is at scale, and when all these questions that you're just asking start coming up, right? Like so yeah, that's what got us here. I wanted to add something, but now I forgot.
I have too many questions. I'm sorry if someone else wants to step in. I just what are like problems which you see which are not yet solved with observability or monitoring? So what is not the immediate roadmap you have for this year, but what is probably the 3-year or 5-year vision you have?
Okay, so way further down the line, closer now, we're helping with onboarding, helping people to get started with open source and everything. But really further down the line, I mean, first things first, Grafana is awesome, and Grafana is the de facto standard to go query Prometheus data. But Grafana is unfortunately also not that easy to use. You saw me click around, like mess up 1,000 times, like not have, I didn't even have like beyond dashboards, I didn't even have a session that I could show you that is like, this is the demo, right? Like, so we do believe that it should be much more collaborative as a UI. It should be much more of a UI where you come in and you say things like, okay, like I have dashboards and so that are fixed, that's great. But what about the ephemeral debugging session? What about the ephemeral moment where I go in and I want to debug my problem and maybe I'll come back to it a year later? So if you use things like Google Docs or Notion or things like this, you just create sessions and you collaborate in the place. And instead of creating complicated dashboards and everything, one should be able to just create documents where they like, I want to add like a little text here. I want to add a little bit of like graphs about certain things. And these documents are live things that in which you can work, debug a problem, link to other things. And so it should be much more, yeah, the UI should be much easier to approach, use, and share, collaborate with. If I want to collaborate with you right now in Grafana, I have to send you a dashboard that I built, which is not easy to do, or I have to, and it's just a static dashboard, or I have to send you 10 tabs, 10 links of my session. Like that's not a good way to work, like especially in a remote world where you can't just get somebody behind your screen anymore, right? So really a more collaborative version and a more intuitive to use version of Grafana would be good. That's the long-term type of stuff that we'd like to build on top of this, right? And then long-term, there are other things, right? Today we use things like Cortex and Loki, and we were thinking, what are we going to add for tracing? But long-term, the world is going towards how do I ask any questions of my system, right? Like, and so the open source databases are not there yet, but eventually we'll get to a place where we can ask, we will have much more links between our logs, traces, metrics, and also random events, and we'll be able to ask much more fluid questions, if that makes sense. But that's not possible today because of the state of open source today, which is fine, right? Like these things don't exist, but they will. And the SaaS vendors are there. And when the SaaS vendors are somewhere, eventually the open source world will be there too. So.
I'd also like to just add there, actually, sorry, Michael, that making the whole experience end to end really simple is important, because you use a product like Datadog, it's really easy to get started. They make it really easy to deploy the agent and, just start using and interacting with your data. And the open source world of observability just isn't like that. If anybody has tried to set up Prometheus and configure it with all of your relabeling and, then Fluentd, once you get deep into all of that, it becomes really, really difficult, and it's too easy to get it wrong. So, we think of observability as the whole system, from where the data lives and where you got to start collecting it right through to having insightful answers to questions that you have. And so collection is going to also be a big area of focus for us to make the whole thing, very simple end to end.
That's really great to hear. I just wanted to add that I've seen that Prometheus provided exemplars allowing to link metrics and traces in one of the recent releases, and you probably will be integrating that, I think. Mm-hmm. And the other thing for tracing is Grafana Tempo, which looks promising as well.
Yeah. No, yeah, this is a cool way, right? Finally, there's a way to start linking metrics to something else, right? Be it traces or something else. And that's fascinating, but it shows, again, that with things like Tempo and all these things, the open source world is very fast moving, and keeping up with it is complicated. So that's one of the things that we want to do, is how do we get people to use things like Tempo or exemplars faster, right? How do we get them to integrate open telemetry code into their systems faster, sooner, right? Why? More people. If you look at how many people are in our community, it's not that many. There's thousands, of course, but there could be more people that just pay and send things to Datadog, to other things. And I have no problem with the SaaS providers, but in the end, paying so much for observability, and in the way that you do when you use SaaS providers, creates wrong incentives, and people stop measuring things. And so we want to get away from that and show them, okay, with open source, you can do it differently. And the world's done it with Kubernetes, right? And this is the kind of stuff that, let's not rebuild the same things over and over and over again, and do something together, right?
Yeah, it's really great. I have a last question. I'm thinking about integrating metric reports and graphs into merge requests or pull requests. You have a staging environment somewhere, it's instrumented with Opstrace, for example, and I want to kind of deploy my application, measure something, and then present it in a merge request. And this is something where I personally want to go and make this happen somehow. So the real question is, how would I start contributing to Opstrace? Where would you say should someone who just tried it, and I really appreciate the Docker Compose demo and making it flexible to generate data, but how would I approach it and say, hey, I want to use this API, or want to add something on top of it, of integrating an iframe or integrating something?
Yeah. So join us on Slack if you want to talk live, or if you don't want to talk live, just start writing in GitHub. We're super open to any issue or anything. If you have the code that we have there, it's all there. It can be a bit daunting, but that's it. Either talk to us on Slack or on GitHub. I think these are the to talk live. And then we actually we're ready to onboard people and with their ideas. This is quite we're quite open to people coming with their own ideas, right? Even if this thing seems quite opinionated, this is how it's built. So yeah.
I think you need to have some sort of opinion, because otherwise it will be like ending up in chaos somehow.
Exactly.
Do you have any sort of like development documentation or contributing MD or something?
Absolutely. So here on
like the opening up.
Yeah, on opstrace.com/community, and you can go there, and then that links to a bunch of things, and then you can also go in the docs. And in the docs, we have something called, let's see, more contributing. Contributor guide. There we go. Development environment. This is how to set up your development environment. It's up to date. It works. This is how to write tests for it. Like we explain our workflows. We explain how we write docs. It's even these docs are open and everybody can contribute to them, right? Like so that's where it starts. If I wanted to build it myself, right? Like and you can check out the repo and like there's a makefile that like is quite quick to follow to build it yourself. Where it starts getting complicated, I have to admit, is we require you to have an AWS or a GCP account. And what we're going to be working on is, yes, this is a fully integrated system, but we're going to allow people to run the controller on their own Kubernetes, even if people can hurt themselves very badly with it. That's okay, like because it allows you to, it will make the hurdles to do development easier, right? Like just to get started running it locally. We haven't invested time in that, but we will. That's it.
Thanks. Yeah, I think that's great. You need to start at one point, and you can always iterate and say, hey, there's a different environment to development. So like we added Gitpod to our contribution workflows, and like spinning up something somewhere, and it's super fast in contrast to and contrary to installing Node for 30 minutes, and then you don't know where to start. So I really appreciate that you are having a documentation and an entry point for everyone to get things going. I was thinking.
I have one last question for curiosity, because before we break up. So when you showed the CLI, you said that the CLI will do all the stuff to creating all the AWS resources, right?
Mm-hmm. Yes.
Did you implement it with AWS CDK, or do you use another tool under the hood?
So we use the Node libraries so basically the SDKs, not the CDK itself, like but the SDKs for Node for Google and for AWS. And so we then call the functions
okay.
But it's a bit more than that. Like Matt is the one who actually like did it in the beginning. It's like there's a whole system there where we basically the reason we did this in TypeScript in the beginning is because of many reasons, but we wanted to have one code base that has the same code everywhere, right? Like whether that's a long-term goal or solution is not necessarily, is up for debate, right? We already have quite a bit of Go code for things like our APIs, right? Like whenever code goes through it live, like metrics goes through something live, APIs, it's all in Go. So yeah, we're open to quite a few things. But it's all, the idea was we needed one code base to not just deploy the system, but also run the system on top of Kubernetes, and also there be able to manage the cloud provider itself, right? What if I want to create a UI to add a node, right? Like to the system, right? Or to autoscale. This needs to happen from within the cluster. So that's why this was started this way. You want to add something, Matt?
Yeah, we iterated and tried a bunch of different approaches here in the beginning. And the natural one in the beginning was to use Terraform and then stand everything up and then deploy things on top of your environment from there. And then we thought, well, Terraform didn't have the flexibility that we needed to be able to have control over the infrastructure and the containers that were also running on top of the infrastructure at runtime. So to do what Seb said, we want the flexibility to be able to control the underlying infrastructure from an API or from, you know, a user interface to be able to horizontally auto scale, for example, as, you know, more metrics are coming in. You might want to create a policy where you can automatically add new machines to the cluster, so that somebody doesn't have to come along and say, oh, the cluster is about to run out of memory, I need to do something about it. So we moved from Terraform to Pulumi because we thought, okay, we can have everything in a common language. And what we found was that Pulumi was still too restrictive for us even then. So that's when we decided to just, you know, narrowly focus on the APIs that we needed and just build our own SDK for those, so that we had full flexibility over all of the infrastructure.
Yeah, that's great. So that was also my intention, so to ask, so why we shouldn't use Terraform for that also, for example, because in most businesses, or also my work, mostly what I write is totally, I write Terraform code mostly. Yep. Or I write some code on the platform, so in Kubernetes, but it doesn't tie it directly to AWS mostly or other cloud providers.
Yes.
Yeah, that's true.
Yeah, our philosophy, oh, sorry, go ahead.
And I really like your idea on vision about the terms of observability, because it reminds me really, I read also a bit about the background from Sebastian. So because he worked on Docker, and Docker had the same space. So containers also exist before Docker, but Docker had the quite right step to enable a lot of more people to use these technologies. And I think this is the right key to get the adoption mostly, so that observability, like you said, it needs to be usable, and not that I need to invest 3 days only to set up all the whole setup and I don't know what to do. I want to get simple in and want to add simple stuff, and the technology should do it, and then I can build up my business case.
Yeah,
absolutely, absolutely.
Yeah, you're just making the case for us. Thank you very much. Yeah. Now, one thing that I want to say about the thing that was why it's all built in one language together, I think it's about testing, right? When we started with this, we wanted to be able to like, of course, the user spins up the cluster once and then is supposed to stay up, and that's it. So install seems like, why do you invest so much in install? Because we actually, on our side, wants to install it again and again and again and again and again and again, so that we know percentage rate of failure, so that we know, like, so that we can actually test the whole thing end to end as much as we want, right? So that we can go spin up anywhere in a branch a version and start building upgrade tests for that place, right? Like, we need to be able to fully automate the testing of a solution like this. And it's doable because, thankfully, it's observability. So there's a signal that goes in, and it's there's a lot of different shapes to that signal, and we'll eventually have tests around these things. So it's a super fun thing to do.
Yeah, and I had also an addition, or now an idea comes into my mind, because you're talking about testing, and I think 2 or 10 episodes before, we used, instead of Fluentd, we used Vector. Probably you know the log shipper, and they had also a test framework in where you can also test your log shipper directly. So it's also really cool.
Yeah,
to use that.
Yeah, that's cool. Yeah, we looked at Vector. We haven't played with it just because, like, you can't play with everything, but like it has a lot of cool ideas, and it's pretty nice.
Yeah.
Vector is very cool.
Cool.
Probably I'll make a pull request how to integrate it in Opstrace.
Yeah, go ahead. Feel free if you find an idea.
Yeah.
Anyone else? Any questions? It's been, wow, 1 hour and 25 minutes. Okay, like I didn't see the time pass.
You probably missed some meetings.
No, all good. We took time. You said this would take more time, so
maybe one last question. What was the intention to build Opstrace? Was there an event or something like that, or an idea which grows over time?
Yeah, I mean, it grew over time into what it is now, but the first part was, observability. Like, if we interviewed a lot of companies and we asked them of different sizes, and we asked them the same questions, right? How do you manage your infrastructure? What do you do, right? Infra questions. In these questions, obviously, when you talk about infra, is monitoring, logging, observability, and all this, right? And after we had all that data, after looking at it, Matt looked at it for a while and reordered it, and it became quite clear that there was still a problem with observability. And honestly, it was kind of a surprise because in our head, we were like, yeah, we love Prometheus and all these things, so fine, right? Like, and on the other side, it's like people who can use Datadog and other things. But turns out, like when we talk to these companies, there's still so much to build. And then the idea kind of iterated, right? In the very beginning, we wanted to build what I said about our commercialization strategy, a SaaS that runs in the company, in the company's network, right? So in the beginning, we said, we're going to build Datadog, and Datadog is going to run in your account. And then we started iterating and seeing that we use all these open source projects, right? We're like, we're standing on the shoulder of giants. Like, we can't just like, if it's closed, it's like, nah, it doesn't work. So we continued to iterate and like, okay, like, and we were quite inspired by GitLab, to be very honest, right? About how in the open GitLab does things and talks about what they're doing and everything. And we're like, okay, GitLab and others. And I spent a bit of time at Red Hat and all these things were like, okay, let's just make an open source project. It's different, it's harder, it requires a community, right? Like you can't just do it by yourself, but this is what we're doing now. We're saying, let's build a community to do this, because we're not the only ones with this problem. And then the companies that we're going after right now, and like, sure, we're doing POCs where we manage it for some, but like most companies that we want to talk to are companies that said, okay, we have already decided not to buy something, right? Datadog or something. We want to build something with open source. And then we tell them, cool, let's build this together. Don't re-implement everything. You want to re-implement auth, TLS, all these things again and again and again and again. Like that's not the core business of companies. And so that's exactly how we got to what we're doing today.
So I have a really last question or recommendation. Yeah, I shared it on Twitter already. I could talk all day about monitoring and observability. In the enterprise environment, it's oftentimes you have some classic service monitoring, and then you do state-based SLA reporting and generating nice PDFs with a cake diagram and some other fancy things. I know that you can do it in a certain way with Grafana, but I think like to enter the enterprise, or to enter the ops or admin personas who want to present reporting to their managers and just sending them PDFs, I think it would be a great asset or a great way to have this provisioned or have this as a template available, and you can customize it in an easy way, maybe in the future with an UI, and kind of making people say, hey, I want to use Opstrace just because the reporting is awesome. And it's so easy. This is, I think, one of the things I had like heard so often in my past when maintaining Isinga, and it was really hard to fulfill as an open source project, because normally people want to pay for that or do pay for that because the PDF export is an enterprise, like in Kibana. And I could think of, like, if you want to find the special case, SLA reporting in the boring way could also be an entry point, similar to incident management. Which brings me to another idea of integrating GitLab incident management with Opstrace. I will hopefully find someone who does it, or I will do it myself.
Cool. These are exactly, the premise of what we stand for too, is, trying to talk to people like yourself, who think of all these different things that they might want to get done with such a platform. And that's what excites us each day, to think about all the various possibilities and to work with people to try and make this stuff happen. So, I say, please keep the ideas rolling, and come chat to us in Slack, and let's see what we can get done.
Yeah, for sure. And it's like, we're in it for the long haul. We know that this is a big project, right? Like, but I don't want to join another company one day and have to like choose monitoring again. Like, this is not like, just like next time I want to use Kubernetes or whatever the state of the art of that moment is. Not saying that Kubernetes will be this forever, but that's it. Yeah.
I think from a developer's perspective, or from my backend engineer head, it would be amazing to have some sort of APM or tracing or instrumenting out of the box, because I really struggle of watching an SDK or looking at an SDK for OpenTelemetry and trying to understand how to add instrumentation to my app. I don't know where it fits. Does it affect the performance? And those are all things at the top of my head, which I want to help solve, but I currently don't know. And if we can do, if you go into that direction or plan to go, I think lots of people will love Opstrace because it just works, and you don't need to figure out how to configure something. Because as a developer, I don't care if it's Kubernetes or whatever. I just want my app being deployed. I want to see the metrics, and I probably want to be alerted or see some reports.
Yeah.
But how this works in the background, maybe for debugging. But in the end, I want to be fast and focus on the fun stuff, which is code, or which is seeing my application being run in production.
Exactly. Right, and that's the point. It's you want to build and focus on your own, problems that you're trying to solve, and monitoring by now shouldn't have to be one of those things that you also have to focus on. And so, we think of that as our job, and we want to make sure that other developers like yourself don't have to think about it too deeply. It just works.
Yep, and security teams don't have to worry because everything is TLS secured, and you probably could also harden security and say this cipher is not allowed because company policies forbid that, and things like that, because security is super complicated.
Yep. Also, locked security is really complicated. So, for example, if you're thinking on Germany, you have the GDPR, and you need to check that all your logs are currently shipping it. And when for most teams that I'm currently working on, I try to work with the developers and say, don't put this information in the logs, then we don't have problems. Otherwise, you need to do it on the other end. So they need to put it into Fluentd or some having expressions to check that the stuff is not there and so on. Yeah. It's also what could be a really cool use case to see how to do this on different compliance levels, at least, because some of the enterprises are struggling with it at least as well.
Yeah, it is a use case. Sorry to interrupt you, Matt, but like in the past, we've worked with enterprise companies who had those problems. We ourselves have to be GDPR compliant too, even if we're in the US, right? We know how it works. And you just build an architecture where the logs don't exit the company's domain, and if it doesn't exit the company's domain, you don't have a problem, right? Like you don't even have to prove that you're deleting them, because by law they're there and they're fine, right? Like Matt, you wanted to add something?
Yeah, I wanted to say that also the beauty of having an open source project which is extendable, and particularly when you have an architecture like ours where we have the flexibility to deploy new pieces or new containers into the logging pipeline, for example. There's no reason that we couldn't create a way to inject a scrubber or something like this too, in your pipeline, so that if you do have really sensitive data that developers are accidentally logging, that you can still take control of scrubbing that data out on the Opstrace platform end of the system. So things like this, provides, that's an example of how the security team, for example, can take more control over the matter without having to sort of bang on developers too much and tell them, hey, stop doing what you're doing. They can say, actually, like, oh, I'm just going to make sure that the data doesn't get stored in the database, that it shouldn't be stored there.
Cool. All right. I think, unless I'm happy to answer more questions, I think Matt as well, but up to you guys.
I think everyone is installing it now. Niklas?
Okay.
Niklas?
Perfect.
No, I don't do it right now. I've prepared everything, but mostly not yet. I need to do some maintenance work, and afterwards I can do it. Or when waiting on pipelines.
Please reach out to us. We'd love to hear about your experience with it. And if you have any questions along the way, we'd love to help you in Slack too.
Yeah, I will do.
Awesome. And yeah, we
Thanks.
don't hesitate to say this is crap, this is crap, this is crap. No worries, right? This is what this is about, right? Like we are building something where we know that the final user, most of them are skeptics. Most of them are like, not something like this again, right? Like it's fine. Like been there, done that.
Yeah, thanks for joining today. I would totally love to do maybe a wrap up or like a review from our side in half a year and see how things are going. Like you joining again and sharing the latest demos, the latest things. It could also break. We love debugging together. And thanks for taking the time today. If there are no further questions, I would just wrap it up and say thanks for attending. I will write a blog post or just publish the blog post later on. And the recording is on YouTube, but we're all on Twitter. And we can also link LinkedIn and stuff. But with that, I would say we're saying bye on YouTube, but we can still